Hello and welcome to this revision session for Paper 2 in AQA A-Level Physics, and in today's revision session we're going to look at how to answer examination questions on A-Level Physics Paper 2 and in particular multiple choice questions. So if we've been successful and we've learned in today's lesson, we'll be able to answer A-Level Physics examination style questions, assess our understanding of A-Level Physics, and understand what topics we need to improve upon for AQA A-Level Physics. So how should you be carrying out this revision session? Well, when you complete your work in this revision session, divide your piece of paper into two sections. Make the section on the left hand side larger than the right hand side, and in this section write down your working out and answers to the questions in the revision session. When you're doing this, make sure you write in full sentences and show your full working out. Whilst in the right hand side, write down any bits of information which you find useful or any hints and tips on answering questions from this revision session. And at the end of the revision session, write up these notes into a revision sheet for you to use independently. So how should you be revising AQA A-Level Physics? Well, the first step is to learn the key facts. So use revision guides, class workbooks, student prep notes and the textbook to learn the key ideas of the course. The second step is to test yourself. So use things like Caboodle, Seneca, knowledge checkers to quickly test your own knowledge. The third step is then to use exam prep books, homework books, supervised study books, additional workbooks to answer exam questions and mark your own work. So the three steps of learn the key facts, testing yourself and practicing exam style questions are how you should revise AQA A-Level Physics. So let's have a look at some questions now on the paper 2 topics for the multiple choice section of the paper. So let's have a look at gravitational fields. So the first question says the radius of a planet is r. The gravitational potential of the surface of the planet due to its mass is minus 4,000 joules per kilogram. What is the gravitational potential at a distance of 2r from the centre of the planet? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is going to be B, because we know that V, the potential, is minus gm over r. So this tells us that if r doubles, well therefore the potential halves. So therefore when it's at 2r, the potential is half, so it's now gone from 4,000 to 2,000, the answer is B. The next question says gravitational field lines and lines of equipotential, and then you've got to finish the sentence. So pause the video now, then unpause the video when you want to go through your answers. Right, the answer here is going to be D, because it's a fact that the lines of equipotential are always perpendicular to the field lines in all gravitational fields. So by that logic, the only answer possible is D. The next question says, in the graphs below, r is the radius of the Earth. Which graph shows the variation of the gravitational potential V with a distance d from the surface of the Earth? So pause the video now, then unpause the video when you want to go through your answers. Right, so in this one, we know that the gravitational potential is always a negative value by definition, so A and B cannot be right, so it has to be either C or D. So there must be a non-zero value of the potential at the surface, because we take the potential as being measured from the centre of the planet, so therefore our answer must be D, so the answer therefore is D. The next question says, satellites X and Y orbit the Earth at distances r and 4r respectively as shown in the diagram. Which statement is incorrect? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, we know that as t squared is directly proportional to r cubed, Kepler's law of orbits, the further away the satellite, the slower its orbital speed, and therefore y will be going slower than x. So from that idea, the only correct answer can be A. The next question says, which of the following gives a correct unit for g squared minus g? So pause the video now, then unpause the video when you want to go through your answer. Right, for this one, we know that big G has units of N to kilograms to the minus 2, M to the minus 2. We know that from the equation sheet. And small g has units of newtons per kilogram. So therefore, we can pop that in and we can say G squared over G is N squared kg to the minus 2 over N kg to the minus 2, M to the minus 2. The kg's cancel through. We then have n squared over n m to the minus 2, so therefore one of the n's cancels through, so it's therefore n m to the minus 2, so our answer is therefore D. The next question says, Ganymede and Io are two moons of Jupiter. The orbital radius of Ganymede is greater than the orbital radius of Io. Which row shows the moon with a greater orbital speed and the moon with a greater angular speed? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? As we mentioned before, t squared is directly proportional for r cubed in Kepler's law of orbits. So the further away the moon is, the slower the orbital speed it will have, because the time it takes to orbit will be slower. So therefore, the slower the orbital angular speed. So our answer is going to be A. Now the next question says, a planet has a radius half the Earth's radius and a mass a quarter of the Earth's mass. What is the approximate gravitational field strength on the surface of the planet? So pause the video now, then unpause the video when you want to go through your answer. Right, so for this question we know that the gravitational field strength is equal to gm over r squared. That's from the equation sheet. So this tells us that if the radius halves, then g will increase by a factor of 4 because it's g to the proportion of 1 over r squared. We know that the mass decreases by a factor of 4, so therefore the two values cancel each other out, so therefore g is going to be unchanged, and we know approximately on Earth that g is 10 newtons per kilogram, so the answer is C. Let's now have a look at some questions on the electrical fields topic. So the first question says, the diagram shows a uniform electrical field strength E of 20 volts per meter, a charge of 8 millicoulombs along a path of JKLM. The distance of J to K is 2 meters, the distance of K to L is 1 meter, and the distance of L to M is 1 meter. What is the net work done moving the charge from J to M? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, we know that for row A, okay, we know that the electrical field strength requires R to be squared. So what we can say is that work done is Q times delta V. So therefore we know that 8 times by 10 to the minus 3, because that's its charge, millicoulombs into coulombs. Then we work out what its change in potential is. So it's from 2 minus 1 times by 20, because then we're going to work it through our change in potential like so. Okay, and then as a result, so therefore it's 0.16 joules, so that works through to be 160 millijoules. So our answer is therefore A. The next question says, two fixed parallel plates X and Y are at constant potentials of plus 100 volts and plus 70 volts respectively. An electron travelling from X to Y experiences a change of potential energy, for which line A to D in the table shows correctly the direction of the electrostatic force F on the electron and the value of the electrical potential energy. So, pause the video now, then unpause the video when you want to go through your answer. Right, so the work done, which is the electrical potential energy, is Q times by delta V. So the charge is the charge of the electron, which is 1.6 times 10 to the minus 19, times by the change in potential, which is 100 to 70, which is 30. So therefore our work done is 4.8 times 10 to the minus 18 joules. Now we know that 1 EV is 1.6 times 10 to the minus 19 joules, so therefore the work done in EV is 1 divided by the other, so it's 30 EV. Now work is being placed out of the system because it's going down the potentials. Now the force acts in the opposite direction of the electron, as the force takes a direction a positive charge would take and the electron is a negative charge, so therefore our answer is A. The next question says the electrical potential at distance r from a positive point charge is 45 volts. The potential increases to 50 volts when the distance from the point charge decreases by 1.5 meters. What is the value of r? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, we know V is directly proportional to 1 over R. You can work that out from the equation given to you on the examination sheet. Now V has increased by 10% because 5 over 50 times by 100 is 10%. So this means the distance must have decreased by 10% because they're in inverse proportionality to each other. So if 10% is 1.5 meters, well therefore we can work out that 100% is therefore going to be 15 meters. So therefore our answer is 15. The answer is D. The next question here shows the diagram with electrical field lines around 3 charges, Q1, Q2 and Q3. Which row gives the signs of the charges Q1, Q2 and Q3? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, electrical field lines move in the direction that a positive charge would take. Now Q1 and Q2 are therefore positive because the field lines are moving away from them and positives will repel other positives. Now Q3 is a negative because the field lines are moving towards it because positives want to go to negatives. So our answer is D. The next question says, the diagram shows 4 point charges, each plus Q, at the corners of a square of side 2A. What is the electrical field strength at P, the centre of the square? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer here is A, because the electrical charges cancel each other out as they each have the same charge and they're equidistant away from each other. So therefore, the overall electrical field strength, which is a vector, will cancel each other out because they're all acting at the same strength at the same distance from that centre point P. The answer is A. The next question says, a deuterium atom consists of one electron and a nucleus. The nucleus has one proton and one neutron. The electrostatic force on an electron due to the deuterium nucleus is Fe, and the gravitational force on the electron due to the deuterium nucleus is Fg. So what's the ratio, Fe over Fg? So pause the video now, then unpause the video when you want to go through your answer. Right, so to answer this question, you've got to work out the electrical force. Now we look on our equation sheet and we see that it's F is equal to K Q1 Q2 over R squared, and the gravitational force is F equals G M1 M2 over R squared. Pop in the numbers. Now you'll notice as well, because they both have the term R squared in, you don't actually need to know the value of R because they'll just cancel through when you divide one by the other. So therefore you can work it through without considering R squared, so we get our answer out to be 1.1 times 10 to the 39. The answer is C. The next question says, an electron moving with a constant speed enters a uniform electrical field at right angles to the direction of the field. What is true about the force acting on the electron? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is B, because the field lines show the direction that a positive charge would take if it's placed there. So as the electrons are negatively charged, the electron will move in the opposite directions to the field line, and if the force is perpendicular to the direction of the motion, well then the force will change the direction but not the speed of the particle, because acting as a centripetal force. So therefore our answer is B. Right, we'll now have a look at some questions concerning capacitance. So, the initial charge stored by a capacitor of capacitance 0.50 microfarads is 2 microcoulombs. The capacitor is then discharged through a resistor. How much energy is stored by the capacitor after a time equal to one time constant? So pause the video now, then unpause the video when you want to go through your answer. Right, for this one, the answer is B, because after one time constant, the charge by definition will have dropped to 37% of its initial value. So 37% of the initial value is 7.4 times 10 to the minus 7 coulombs. We then know from the equation sheet E equals a half Q squared over C. Capacitance is a fixed term, so therefore we just know it's 2 times 10 to the minus 6, because this microfarads is given in the question. So working it through like so. So you work it out to be 5.4 times 10 to the minus 7, which is 0.54 times 10 to the minus 6. So it's going to work it through to the answer to be B. The next question says, a capacitor of capacitance C has a charge Q stored on the plates. The potential difference between the plates is doubled. What is the change in the energy stored by the capacitor? So pause the video now, then unpause the video when you want to go through your answer. Right, so how to answer this question? Well, the original stored by the capacitor is equal to a half Q times by V squared. The equation is given to you on the equation sheet. So if the potential difference is doubled, well therefore the energy will quadruple because E is directly proportional to V squared. So the new energy is equal to 4 times by a half QV squared. So therefore it's 2Q V squared. So the energy change is going from 2QV squared minus a half QV squared, which is 3 over 2 QV squared. Now as we know C is Q over V, well therefore the energy change is going to therefore be 3 over 2 Q squared over C. The next question says, the graph shows how the charge on a capacitor varies with the potential difference across the capacitor. What is the additional energy stored by the capacitor when the potential difference increases from 200 volts to 400 volts? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is C, because to find the additional energy stored, you've got to find the area between the 200 volts and the 400 volts on the graph, because the area under the line is your energy stored. So you work out the area between 0 and 200 volts, so it's a half times by 2 times by 10 to the minus 3 times by 200, it's just the triangle, so it's 0.2 joules. Then do the area between 0 volts and 400 volts, so it's a half times by 4 times 10 to the minus 3 times by 400, remember 10 to the minus 3 is because it's in millicoulombs on the y-axis, so therefore it's 0.8 joules, so therefore the difference is 0.6 joules. Our answer is C. The next question says, which of the following statements about a parallel plate capacitor is incorrect? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer is C, because we know that capacitance is charge over volts over potential difference, therefore charge is equal to capacitance times by potential difference. So it indicates to us that charge and potential difference are in direct proportion for a constant capacitance, which is true for a parallel plate capacitor. So our answer is therefore C. The next question says, a capacitor of capacitance 10 microfarads is charged through a resistor R to a potential difference of 20 volts using the circuit shown. When the capacitor is fully charged, which of one of the following statements is incorrect? So pause the video now, then unpause the video when you want to go through your answer. Right, so when a capacitor is fully charged, the potential difference across the capacitor equals the potential difference of the EMF source. That's just a fact. And the PD across the resistor is 0 because there's no current, because it's fully charged. So therefore, if we say E equals a half CV squared from the equation sheet, we can say it's a half times by 20 squared, the capacitance, times by 10 times 10 to the minus 6, sorry, that's the potential difference, sorry, times by 10 times 10 to the minus 6, which is the capacitance. So therefore, our answer is 2 millijoules. Now, however, in the charging process, the energy will be lost to resistance, so therefore it's going to be slightly less than 2 millijoules. So therefore, as a result, the answer is B. The next question says, a parallel plate capacitor is fully charged and then disconnected from the power supply. A dielectric is then inserted between the plates. Which row correctly identifies the charge on the plates and the electrical field strength between the plates? So pause the video now, then unpause the video when you want to go through your answer. Right, so the point is, in this particular question, the dielectric will not affect the charge as the capacitor is fully charged and disconnected from the power supply, so it's unable to be changed. Now the dielectric will decrease the electrical field strength since the polar molecules of the dielectric will align anti-parallel to the capacitor's electrical field. This will produce an electrical field in the opposite direction, reducing the capacitor's overall electrical field strength because it's a vector, so therefore our answer will be D. The next question says, a 500 microfarad capacitor is charged to a potential difference of 10 volts. It's then discharged through a 100 kilo ohm resistor. What is the time taken for the potential difference to fall from 10 volts to 5 volts? So pause the video now, then unpause the video and you'll want to go through your answer. Right, so how do you answer this question? Well, we know that from the work we've done in capacitors that the time to half is log 2 to the times by the time constant, which is log 2 RC. So we can do log 2 times by the resistance, which is 100 times 10 to the 3, because we go from kilo ohms to ohms, times by 500 times 10 to the minus 6, because we go from microfarads to farads. So we pop that through and we get 35 seconds out. The answer is A. Let's now have a look at some questions concerning thermal physics. So, a 60 gram solid metal sample is heated by an electrical heater. The heater operates at a voltage of 230 volts with a current of 1 amp. The temperature of the sample changes as shown below. What is the specific latent heat of vaporization of the metal? So pause the video now, then unpause the video when you want to go through your answer. Right, so we know that the equation is E equals ml, so therefore L is equal to E, or work done over the mass. Now the work done is going to be power times by time, so therefore the power in an electrical circuit is VI, so it's VI times by T over M, so we can pop the values in. We can do 230 times by 1 times by 64 divided by 0.060 grams into kilograms, and we get 245 times 10 to the 3, so it's approximately going to be D. The next question says, a 1 kilo ohm resistor is thermally insulated and a potential difference of 6 volts is applied to it for 2 minutes. The thermal capacity of a resistor is 9 joules per Kelvin. The rise in temperature in Kelvin is what? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, we've got potential difference and we've got resistance. So we can say that power is V squared over R. So we pop in the numbers, we say it's 6 squared over 1000 because kilo ohms into ohms. So it's 0.036 watts. Now because energy is power times by time, if we then multiply it by the time, 2 minutes in seconds, 120, we get our energy to be 4.32 joules. Now we know E equals MC triangle T. So therefore triangle T is E over MC. So it's energy over the mass times by the specific heat capacity, so it's 4.32 over 1 times by 9, so therefore it's 0.48 Kelvin. The answer is C. The next question says, a raindrop of mass m falls to the ground at its terminal speed v. The specific heat capacity of water is c and the acceleration of free fall is g. Given that 25% of the energy is retained in the raindrop when it strikes the ground, what is the rise in temperature of the raindrop? So pause the video now, then unpause the video when you want to go through your answer. Right, so to answer this question, we can say that the kinetic energy, half mv squared, is equal to the thermal energy, mc triangle t, but only by a factor of 25%. So we've multiplied that kinetic energy by 0.25. So it says that's the energy that's being transferred across. So we can then rearrange it and say, well, a half mv squared equals 4mc triangle t. We can then rearrange it to make triangle t the subject, and triangle t equals mv squared over 8mc. The m's cancel through to get v squared over 8c. Our answer is D. The next question says, the temperature of a room increases from 283 Kelvin to 293 Kelvin. The RMS speed of the air molecules in the room increases by a factor of what? So pause the video now, then unpause the video when you want to go through your answer. Right, so we know that from thermal physics, a half mc squared is equal to 3 over 2 kt. Now we know that in this case, the mass and k are constants, so therefore we can say that 3c squared is equal to t, or proportional to t, so therefore c is directly proportional to the square root of t over 3, so therefore it's directly proportional to the square root of 10, which is the change in temperature, from 283 to 293, divided by 3, so we work it through to be 1.04, our answer is B. The next question says, a fixed mass of an ideal gas initially has a volume V and an absolute temperature T. Its initial pressure could be doubled by changing its volume and temperature to what? So pause the video now, then unpause the video when you want to go through your answers. Right, so we know the ideal gas equation is PV equals nRT, so therefore P is equal to nRT over V. Now to double P, you could either half T or quarter V, so therefore our answer is going to be B. Now, a fixed mass of gas occupies a volume V. The temperature of the gas increases so that the root mean square velocity of the gas molecules is doubled. What will the new volume be if the pressure remains constant? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, we know that V over T is a constant, that's a fact. So volume increases at the same proportion that temperature increases if it's going to be a constant value. Now we also know that temperature is directly proportional to speed squared, c squared. So therefore, if c is doubled, well then for T would have to be quadrupled. So if T is quadrupled and it stays in the same proportion as V, well therefore V quadruples, so our answer is D. The next question says, which one of the graphs below shows the relationship between the internal energy of an ideal gas and the absolute temperature of the gas? So pause the video now, then unpause the video when you want to go through your answer. Right, so here we know that the temperature and the internal energy must be in direct proportion to each other. Now because absolute temperature is used, so it's kelvins that's being used, it therefore must cross the x-axis at 0, because we know that with the absolute temperature scale, when there's no energy, there's no temperature. So it must go through 0, 0. So the only answer possible is A. Then let's have a look at some questions concerning magnetic fields. So this question says, three identical magnets P, Q and R are released simultaneously from rest and fall to the ground from the same height. P falls directly to the ground, Q falls through the centre of a thick conducting ring, and R falls through a ring which is identical except for the gap cut into it. Which of the statements below correctly describes the sequence in which the magnets reach the ground? So pause the video now, then unpause the video when you want to go through your answers. Right. So what we should know is the answer is A, because P and R will arrive together because they'll both fall freely under gravity. Now Q will arrive later as the magnet passes through a conductor, which will cause a change in the magnetic flux linkage, which causes an EMF to be induced in the conductor and produces a current. This will produce a magnetic field in the conductor, which acts in the opposite direction to the motion of the magnet due to Lenz's law, and therefore repels it. Now this doesn't occur in R because R is not a complete circuit. So whilst an EMF is produced, there's no current which leads to a repulsive magnetic field. So our answer is A. The next question says, the graph shows how the flux linkage through a coil changes when the coil is moved into a magnetic field. The EMF induced in the coil is what? So pause the video now, then unpause the video when you want to go through your answer. The answer here is B, because when there's a change in magnetic flux linkage, an EMF is induced. When there's no change in magnetic flux linkage, there's no EMF induced. So after t equals 0, it's a flat line, so there's no change, so EMF is 0. Before t0, there's a constant change because there's got a constant gradient, so therefore a constant EMF is induced. The answer is B. The next question says, using the circuit shown and with the switch closed, a small current was passed through the coil X. The current was slowly increased using a variable resistor. The current reached a maximum value and was then switched off. The maximum reading on the microammeter occurred when what? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer is C, because the current is induced in a circuit when an EMF is induced. Now, an EMF induced is directly proportional to the change in magnetic flux linkage. So the bigger the change in flux linkage, the greater the reading. Now, the biggest change, either positive or negative, is when the current is switched off, because all of the flux linkage is removed. This gives you the biggest change, so our answer is C. The next question says, a student is using an oscilloscope to investigate an AC voltage waveform when the input voltage is sensitive on the scale to be 1 volt per division and the time base setting is 10 milliseconds per division. The trace appears as follows. The student then changes the input sensitivity to 2 volts per division and the time base setting to 20 milliseconds per division. What will be observed whilst applying the same signal to the input terminals? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer here is D. So because the time base is being made larger, you'll have more waveforms being fitted onto the screen. And whilst the Y gain is being made larger, that tells us our waves are going to appear smaller than they have before, because each division is worth more. So therefore our answer is going to be D. The next question says a transformer has 1200 turns on the primary coil and 400 turns on the secondary coil. A primary coil draws a current of 0.25 amps from a 240 volt AC supply. If the efficiency of a transformer is 83 volts, what is the current in the secondary coil? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is going to be C, because we know from the equation sheet that MP over VP equals NS over VS. That's the transformer turns equation. We can pop in all the values, and then before we see VS is equal to 240 times by 500 over 1200 to equal 100. Now the power in the secondary equals the power in the primary times by a factor of 0.83 because it's 83% efficient. So therefore we can pop in our values and we can say I equals 0.25 times by 240 times by 0.83 over 100, which is 0.50 amps. Our answer is C. The next question says, which one of the following statements concerning power losses in a transformer is incorrect? Power losses can be reduced by what? So pause the video now, then unpause the video when you want to go through your answer. Right, so power losses can be reduced by either laminating the core to reduce eddy currents, by using thicker wires as it lowers the resistance because the cross-sectional area of the wire has increased, or by using a soft magnet to reduce hysteresis. So the one that doesn't reduce power losses is the high resistance widens. The answer is B. The next question says, a coil with 20 circular turns, each a diameter 60 mm, is placed in a uniform magnetic field of flux density 90 milliteslas. Initially, the plane of the coil is perpendicular to the magnetic field lines as shown. The coil is then rotated about the vertical axis by 90 degrees in a time of 0.20 seconds so that its plane becomes parallel to the field lines as shown in figure Y. Assume the rate of change of flux linkage remains constant. What is the EMF induced in the coil? So pause the video now, then unpause the video when you want to go through your answer. Right, so we know induced EMF is equal to the change in flux linkage divided by the change in time. Now when the angle is 0 degrees, the flux linkage is 0. Now when the angle is at 90 degrees, it's 90 times 10 to the minus 3, because it's BAN, times by the area, which is pi r squared, so it's pi times by 30 times 10 to the minus 3 squared. Remember the diameter is 60 millimeters, so the radius is 30 millimeters. Then you times it by 20, which is the number of turns. Then you divide that all by the time, 0.20. Our answer is 25 times 10 to the minus 3 volts. Our answer is C. Let's now have a look at some questions concerning nuclear physics. So after 64 days, the activity of a radioactive nuclide has fallen to 1/16 of its original value. So the half-life of the radioactive nucleus is what? So pause the video now, then unpause the video when you want to go through your answer. Right, so if in 64 days the activity has gone to 1/16, well therefore working backwards there's been 4 half-lives because we've gone from 1 to a half to 1/4 to 1/8 to 1/16, so therefore we've had 4 half-lives. So if there's been 64 days and there's been 4 half-lives, there's 1 half-life every 16 days. Our answer is D. The next question says, the sodium isotope is a radioactive isotope that can be produced by bombarding the aluminium isotope with neutrons. Which line in the table correctly represents the production of sodium from the aluminium isotope and its subsequent decay? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is B, because the sodium isotope is produced with the release of an alpha particle. And since the sodium isotope, you can tell, because it's 2411, is neutron rich, well therefore, if neutron rich isotopes decay via the beta minus decay, so our answer is B. The next question says, in the Rutherford alpha particle scattering experiment, alpha particles have the same energy with fired at the gold nucleus. Now the diagrams below are intended to represent encounters between the two alpha particles and the gold nucleus N, and the alpha particles arriving at different times. Which one represents the best possible encounters? So pause the video now, then unpause the video when you want to go through your answer. Right. Now, the important thing to note is the alpha particles repel from the nucleus because they're both positively charged, and the closer the alpha particle is to the nucleus, the greater the repulsion will be, because it's the electrical force which links into the distance they are from each other. So therefore our answer will be A. The next question says, the diagram here shows the path of an alpha particle deflected by the nucleus of an atom. Point P on the path is the point of closest approach of the alpha particle to the nucleus. Which of the following statements about the alpha particle on this path is correct? So pause the video now, then unpause the video when you want to go through your answer. Right, so at the closest point between the alpha particle and the nucleus, all the kinetic energy of the alpha particle has turned into the electrical potential energy, and so therefore the alpha particle will reduce its movement to a minimum value. So the answer is therefore D. The next question says, the actinium series of radioactive decay starts with the isotope of uranium of mass number 235 and atomic number 92. Which line in the table shows the nucleon and proton number of the isotope after the emission of 5 alpha particles and 2 beta minus particles? So pause the video now, then unpause the video when you want to go through your answer. Right, so in alpha particles in alpha decay you lose 2 protons and 2 neutrons. So therefore in 5 alpha particle events you'll lose 10 protons and you'll lose 20 nucleons, 20 protons and neutrons. Now in the beta minus decay you're going to gain a proton and you're going to lose a neutron. So therefore in the 2 beta decays you're going to gain 2 protons but gain 0 nucleons because you've turned your protons into neutrons. So overall you've gained 8 protons, okay, and then you've lost 20 nucleons, so therefore our answer can only be C. Now the next question says an alpha particle moves with 1/10 the velocity of a beta particle. They both move the same uniform magnetic field at right angles to their motion. What is the magnitude of the ratio of the force on the alpha particle compared to the force on the beta particle? So pause the video now, then unpause the video when you want to go through your answer. Right, so because they're both charged and moving through a magnetic field, we know that F equals BQV. Now B is constant for each particle, so we can just ignore that in our ratios. Now the alpha particle has double the charge of the beta particle because it's got 2 protons to 1 electron, yet has 1/10 of the velocity compared to beta from the question. So therefore we've got a ratio of 1/5, so therefore the answer is B. Now, a radioactive nucleus emits a beta minus particle, then an alpha particle, then finally another beta minus particle. So the final nuclide is what? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is A, because a beta particle turns a neutron into a proton, and this happens twice, so the proton number must increase by 2. Now alpha emission releases a helium nucleus, so it reduces the proton number by 2, so therefore the proton number must be staying the same, but the neutron number has changed, so therefore it's the original element, but it's an isotope because it's changed the number of neutrons. The next question says, which of the following best describes the decay constant for a radioactive isotope? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is D, because you know that the decay constant is log 2 over the half-life. That's an equation given to you on the equation sheet. So this therefore means that the constant proportionality linking the rate of decay and the number of nuclei, K, must be the decay constant. So therefore our answer has to be D. So that brings an end to our revision session for today. So if we've been successful and we've learned in today's revision session, we should be able to answer A-level physics examination style questions, assess our understanding on A-level physics, and finally understand what topics we need to improve upon for AQA A-level physics. So thank you very much for watching this revision session on paper 2 of AQA A-level physics. Thank you very much and have a lovely day.